In any case, today we're continuing with our class. Today it is lecture number 12. Today we cover peer review process of NIH applications. And I will actually gonna get started with the technical details with respect to how NIH system does perform the review process. And then Mary Kay is gonna go over the details of how to actually write an effective critique and effective review on the grant application. So I'm gonna start sharing my screen in a second. There we go. So that should be coming up. Ta-da. With respect to peer review of the grant applications, it's very much similar to the peer review in general in scientific writing, whether it refers to peer-reviewed publications or peer-reviewed grant application. The peer review system is in place to evaluate the quality of our scientific work, so our grant applications, to be able to answer three critical questions. Is this research idea a new idea? Does it follow good scientific practice? And whether the results are supported by data. In your question, in your case, guys, when you're writing your grant application based for this class, whether the idea is based on the data that has been described previously in the literature. So the review is obviously performed by the experts in the respective fields. The peer review is performed anonymously, meaning that the identity of the reviewers is not disclosed to the applicants. So this is a typically how peer review process is getting done, and all proposals, papers are subject to peer review. Nothing effectively is getting funded unless it was reviewed, unless the reviewers agreed that this is sound work, that this is new, that this work represents new ideas, and this is a good scientific practice, and that this is likely going to lead to the next breakthrough or next good product, and so on and so forth. So with respect to the entire process of how it is done, as you learned in this class, we first start with an idea. We start with a good idea with good preliminary data. In the next phase, as you learn, we write a proposal. And indeed, all of you wrote the first drafts of your proposals during the course of this class. What happens next, after we finalize and polish our grant application proposals, we submit them to the funding agencies. This is usually done through the electronic systems established at our university. Agency, once the grant is received, sends it for the review, and the expert reviewers are performing the review process of the grant applications. The reviewers read through the applications and they write the critiques in a very specific format related to particular agencies. So today we will be covering primarily the NIH type of the review of the reviewers' critiques. It takes about 48 months to get the feedback, so it's a relatively lengthy process. In our case, in our class, everything is obviously very much accelerated. So the outcome for the grant application is based on the reviewers' recommendations. The reviewers themselves do not make the funding decisions, they only write the critiques, and then the funding decisions are based on these critiques. So with respect to the peer review process, the reviews are done individually on a one-by-one basis. What this means is each reviewer writes his or her own review and then submits to the funding agency. Once the reviews are collected and once they're processed, they're getting ranked. Top 50% of the applications are being discussed. The bottom 50% are not being even discussed at the panel. And then the panel meets and discusses the applications, the best applications, so to speak, in the package. So in our case, in the context of our class, what's actually going to happen is each proposal will be reviewed by at least 2 other students. And then what we anticipate is going to happen during the breakout sessions is we will have sort of like an NIH panel, meaning that the reviewers will have an opportunity to discuss the proposal, to be able to figure out whether the reviews were similar, what are the common strengths and weaknesses of the application, where the application requires some more work, and so on and so forth. So in this context, in the context of the reviewers are typically your supporters. Sometimes in case if the application is really weak, these are the people who would actually maybe taking you down. But in the context of our class, your reviewers will be your best helpers, so to speak, because these are the people who will know the deficiency in your application and who will help you to further improve your application text. So what happens after discussion, all panel members vote for the score, and the score gets assigned to a particular grant application. In the context of our class, we're not going to perform the voting, but we're giving you this information to be able to know how the NIH system operates. So in case of the NIH, actually a numerical score will be assigned first to each application. And then in case of both NIH and NSF, summary statement is provided. So this summary statement, these are details, these are critiques which are provided, which describe the strength and weaknesses of the grant application from a particular perspective, as we were discussing, and as we will be covering a little bit more, with respect to 5 key criteria that NIH covers. And then the applications are ranked, and they're sent to the division heads, and then the division heads make the funding decision which proposals are going to get funded or not. So with this, we'll switch to these key slides. As I was indicating previously, there are 5 key NIH criteria based on which the proposals are getting scored. The first one is significance. So again, with respect to your grant application text, significance section is a key section of the application, and the reviewers making their decision on whether your proposal is significant, whether the research you're proposing is significant. The second criterion is investigators, which we're not going to be discussing in the context of this class. Third is innovation. Fourth is approach. And 5th is environment. So environment is also something that we will not be discussing in the context of this class, but all the other 3 criteria, significance, innovation, and approach, we will be discussing during this class. So
Ed, before you go on, there's a question.
Oh, excellent. Thank you.
The question from Sarah is, what would happen if there's a conflict of interest between the reviewer and the author?
Right. So this happens very quite often, actually. So in case if this is a peer review, anything really, whether this is a peer reviewed paper or grant application, it's the job of the science officer to be able to identify the conflict of interest ahead of time, if possible. So but in addition to that, each reviewer is being contacted by the NIH system, and each reviewer is being asked to sign the conflict of interest paperwork to ensure that every proposal that will be reviewed by this particular reviewer does not have the conflict interest. And the conflict of interest may come in all kinds of forms. So, for example, the most common one is the conflict of interest if both the applicant and the reviewer come from the same institution. So very much similar to this NIH conflict of interest, what Mary Kay and I were trying to navigate around our class is to ensure that the reviewers and the reviewed applications during our exercises for the next 2 classes don't come from the students from the same lab. So we didn't manage to do it in all cases, but conflicts of interest exist, and we are trying to mitigate them, and NIH is trying to mitigate them through a number of different ways. So I hope this answers your question. Mary Kay, would you like to add anything?
Oh, that sounds good, Ed. You did a great job. There's actually another question, and this one's from Shiraz. Since reviewers are experts in the area, in the research area, is it possible for a reviewer to have a personal bias against your proposal because it will affect his or her work?
That's a very good question. So it does and does not. So what NIH mandates is NIH mandates that that there should be no bias with respect to the work. But I mean, of course, it's very difficult to make it happen in this particular way. So one advice that I would have is when you're writing the grant application text, you should be as polite as possible with respect to review the particular field, and use very polite and respectful language with respect to what's been done in the field. So what I mean by that is, don't try to say that, well, everything that has been done so far is, barely any novelty, and whatever I'm describing in this proposal is the best thing, and it's supposed to change everything in this field. Mary Kay, your thoughts?
Yeah. So, you've hit upon an issue that's very important to NIH and NSF and our funding agencies. They're very concerned about conflicts of interest, and science is really held to quite a high standard in this sense. So, as Ed suggested, like if there is a conflict of interest, you have to announce them. And what they basically do in the actual study section is you walk out of the room. You don't participate in any way in the review. So, I'd say in regards to your question, Shiraz, if there's a personal bias, it's the responsibility of the reviewer to announce that there's a personal bias and walk out of the room. So if you're a direct competitor, a collaborator, you're basically responsible for announcing the conflict of interest so that you can be removed from the situation. So there's a certain amount of trust that we have in our reviewers that they would announce if they have a personal, you can't review anybody that's in your family, and you can't review anybody that you would have a personal bias. If you feel like you could have a bias, you should just walk out of the room. So I think that's the way it works.
Right, and there is one additional safety net to mitigate all of this. So when a person submits an application, there is a field in the NIH forms to list any people that you would like not to review your application. Obviously, you cannot list everyone in your field, but in case if there are several people who you feel may not necessarily be 100% fair with respect to application because of the potential conflict of interest, whether these are competitors or for some other reasons, you may be able to list those people. It doesn't really mean that they will not be 100% guaranteed to not to review your application, but scientific officers at NIH will do the best they can to be able to mitigate this conflict of interest. Any other questions so far? All right, we're going to move on. So with respect back to NIH, there are, so the way the sort of speak ranking is designed, it goes from 1 to 9. So 1 is really exceptional. These are exceptional proposals. 2 is outstanding. 3 is excellent. So everything that falls in the category of between 1 to 3 is something that NIH would likely to fund. And then there are these other 4 scoring criteria. Four types of scores between 4 and 6. So these are like very good, and satisfactory. These are may be funded, but most likely will not. And then and then the other types of the scores where you hope your application is not going to fall is fair, marginal, and poor. So these are definitely the proposals that are likely not going to get, most likely not going to get funded. All right, so this is how the NIH ranks the proposals. We're not going to use these rankings during our class, but you really should be knowing this scoring system in general if you're ever going to be applying to NIH. So the goal of the reviewing others' work is to improve the quality of the proposal writing, and this is the main reason why we actually perform these activities for next class and the one after the next, is for you guys to review each other proposals to be able to improve on what you've already written so far. So in a way, the nicest thing that you can do for your coworker at this phase, and really at any phase, is to point out to any potential flaw before a real reviewer does. So again, in the context of what you will be doing with respect to your proposals, make sure to catch any holes or weaknesses in the science of the proposals that you will be reviewing. The way we designed the breakout sessions, they're based on your areas of respective expertise, analytical, analytical, organic chemistry, and so on and so forth. So what we anticipate is you will act as people with sufficient level of expertise to be able to review these proposals and potentially identify some of the areas which are very weak. Equally importantly, during this process, we also hope that you will be able to identify the areas which are not written very clearly. And again, if during in this class a reviewer does not fully understand what you mean, it's bad, and it's really much to advantage if the reviewer points out a particular area which is not clear, because you can still improve on. You still get time. So again, in the context of the NIH critiques or grant application critiques, you really need to be constructive. You need to, but remember, you need to be polite but critical. So in case if something is really bad, you need to say that it's actually bad. But again, use a very polite language to be able to explain it. So this is an example of how the NIH critique is going to look like. So this is a review of R21 application. There are several different reviewers who were reviewing this application. So this is what we call critique one. This is how NIH actually provides the materials back to us. And it then provides the scores for every single category. So again, just to remind you all, there are 5 NIH review criteria: significance, investigators, innovation, approach, environment. And then NIH usually provides you with the overall impact description of the particular grant application. So my goal here is to walk you through some of these critiques as examples which have both strengths and weaknesses. So before we're going to go to that, typically at NIH, in case if your score is 1 or 2, the reviewers are really not obliged to provide any critiques. In the context of this class, we would really like you to provide at least 3 critiques with respect to the applications that you will be reviewing for. Whether they're good or whether they're bad, we would still like you to provide the critiques for the people who wrote these applications that you were assigned to review. So, so in case of this particular application, the reviewers list 1 strength. The polarization efficiency will be optimized by pH and temperature manipulation. The evaluating the kinetics of the agent uptake are well described and very rigorous. So basically what the reviewer is saying, this is very rigorous science. The score is 3, which is supposed to be very good based on the NIH ranking. And then the reviewer also provides the details of the weaknesses. The PI plans to deploy the technology on a low field system below 0.05 Tesla for cost purposes and improvements in data quality. This is somewhat counterproductive, as it would suggest that the dedicated low field systems would be useful just for this purpose. It would make more sense to make this available as an add-on study to a conventional clinical scan, which will be performed at 1.5 Tesla and 3 Tesla and have superior image quality for the other imaging components. This is viewed as a minor weakness, So my point here, as for you to see, is this is a very polite language. there are strengths and weaknesses being described. And in case, if in this particular case, the score was not great, like not 1 or 2, the reviewers provide some detailed critiques explaining why their score was less than perfect. So this is very much normal. So we're going to switch to a few other slides. So this is another critique. So here we have, we're not going to be looking at the innovation. We're looking at the approach, which is scored at 4. So again, what is listed here is strengths. So the key strengths of this application with respect to approach, preliminary data supports all aspects of the chemical synthesis of the probe. So that's good. That's very constructive. Weaknesses, animal experiments continue to appear to be an afterthought. As presented, there is a concern that no sufficient time has been allotted to considering how the model manipulations can address the usefulness of the probe, sensitivity, specificity, indirect validation, so on and so forth. So the reviewers here provide a very specific critique that the animal experiments are not being planned adequately to study this particular probe. So again, with respect to your critiques that because you're going to be writing them, make sure that it is detailed, that it describes a particular point. Don't be broad with respect to how you describe your critiques. And Mary Kay, a little bit later in her presentation, will actually expand on how best to write the critique. So with this, I'd like to